And Alana, you think it looks brittle. Oh, you guys are so on top of it today. So yes, this has metallic properties in that it's shiny, it looks like a metal, it's solid at room temperature, but it also has some non-metal properties, like it's brittle. So if you were to hit it with a hammer, it would break into a million little pieces. And hello, Hadassah, how are you today? Oh, I have to pin the chat. I'm recording this so that anyone who missed out on class can view this, or yeah, so I have to keep the chat pinned so it'll show up on my video. And today, this would either be for August 21st, which was yesterday, or for today, August 22nd. It's not as reactive as others. Depends on what it is. Now, this is actually arsenic. And so let me get my periodic table. And arsenic is kind of in the middle over there. It's number 33. And so, yeah, it's a ways away from fluorine. Fluorine is the most reactive over here. And so you have to go up 2 periods and over 2 groups to get to fluorine. So yeah, it's pretty stable. Things along the middle here in group 4 are fairly stable because they have like half of their electrons. What's the total full shell of electrons? How many would you have? Oh, I'm looking at my video on the screen and then I can see what I'm pointing at. So, yes. And everything, it's backwards, you know, the mirror thing. So there's arsenic. Sinai, we just started. This is the very beginning. But I was asking you guys about how many valence electrons are in the outer level for an atom to be stable. Yeah, we need to have 8. And so arsenic has 5. So, you know, it's not as reactive as the halogens are. The halogens are the most reactive. All right, so today we are learning about metalloids, and I just want to remind you about parking it, and also making sure you're logging into Clever every day and going from there to get to Canvas and everything else you need to do. And you guys have fabulous code of conduct when you come in here. Your chat box are limited to lesson content. And you guys are always respectful and courteous, and I really appreciate that. Thank you. Let's do a knowledge check. All right, remember the emojis are down there in the bottom left-hand corner. Which group on the periodic table contains unreactive elements? And hello, Michelle and Kenny. And Solomon, welcome. Welcome, Noah. And Tristan, welcome. The answers are rolling in. Remember, part of your park it is to always participate. So, group unreactive. If they are unreactive, how many valence electrons do you think they'll have? Yeah, they're going to have 8 valence electrons, right? So what group has 8 valence electrons? Which group has 8 valence electrons? You can say that we know it's not the halogens, right? Because we just talked about those having, well, maybe we didn't, that was in fourth period earlier today. We talked about how the halogens had 7 valence electrons. So it's not going to be the halogens. We want to know what group has 8 valence electrons. And I see most of you guys have the right answer here. Well, Kenny, that is good practice on test taking, is that you know how to eliminate the wrong answers. I think that's just as important as knowing the right one, because sometimes, you know, it's easier when you have a tough question to know how to do both, figure out the right one and eliminate the bad ones. So I like to teach you from both directions. Plus, I want to tell those who picked, you know, that picked alkali metals, that's group 1, right? And group 1 has 1 valence electron. These are the most reactive metals, so that cannot be the right answer. So, and then you all should change your answer if you know the right one when you get to it. So group 1, alkali metals, very reactive, so not the answer. Alkaline earth metals, they have 2 valence electrons, which they will readily lose. And so that's not the answer either. The correct answer is the noble gases. And we did pretty good, pretty good. I think we're at like 80%, got that one right. So let's try one that's a little tougher. All right, so which best describes bromine? Ooh, let me clear these. And hello, Dustin. Let's see. So make sure you read the entire answer for these. I'm going to be quiet because this one requires you to think a little bit. And yes, there's a 5th choice here that if you have no idea what you're doing, if you could please give me a red X, and then I'll know that at least you're here participating, but you need a lot of help. So thank you. I got a red X, appreciate it. Hey, Ian. So Connor, Jonah, Michelle, Noah, Solomon, Thomas, and Tristan, I need to know what you think here. Excellent, excellent. That looks a lot better. I'm going to attempt to annotate this. Annotation, it's working, yay. Okay, so I'm gonna look at happy face. We'll start at the top. Bromine is a halogen, is the first little bit there, and here's bromine. It's in group 17, which is the halogens. So check, check, yes, it is a halogen. Is it a metal? That's the thing though, is it's not a metal, is it? Because bromine's over here with the non-metals. All the metals are down over here. Back up. All of that is metals. The metalloids are right along the stair step, and then these are the non-metals. So not a metal, so we have to eliminate happy face. I haven't gotten to the right one yet. Is bromine a noble gas? Well, we just said it was a halogen, so it's not a noble gas. So we can get rid of that one. It's not okay. And look, I'm just looking here. This says it's a noble gas too. So I can get rid of turtle just based on those two things. You didn't necessarily have to understand that bromine will make a -1 charge. But it's good. If you knew that and you didn't know about the halogen noble gas, you could have figured it out that way. So let me just go over that one more time about the charge. Here's bromine. It's in group 17, right? So it has 7 valence electrons, right? And to be stable, it wants to be like a noble gas. It wants to have 8 valence electrons. So in order to get from 7 valence electrons to 8, it has to gain 1, and that 1 electron has a negative charge. So the charge will be -1. Check, check. All right, so make sure if you understand why the loudspeaker is correct, that you change your answer to that. And that way I know that you understand. And if you're sticking with the red X, then when we go to break time, you want to stay here and ask questions or have me come back to this question. Oh, I like that, Sanai, the little extra bit of information about halides being chemical compounds formed from at least one halogen element. And so you've got that little HAL part of the word, and so looking for those common bits of words in science can really help you to understand things better, especially when you run across a word that you don't know. All right, I'm going to turn off the annotation and continue on. All right, so today we've got to identify metalloids. We're going to look at the characteristic properties of them, the location of them, and figure out why they are semiconductors. And what worked out really well last period is that we did the simulation stuff first today, and then we did your lesson later. Ooh, a semiconductor is something that conducts electricity, but not necessarily very well. So it'll conduct some electricity, but nothing like copper or silver or gold. Yeah, that's why it's part of a metalloid. That's part of the sort of like a metal, sort of like a non-metal. So we're going to come back to that. So when you're finished working on the simulations, then you can work on your lesson. And then we'll recap at the very end of our class, which will be around 2:20. We'll recap the metalloid stuff. Oh. Oop. One more. All right. So I definitely want to get to the simulations. And so today I wanted to spend a good 20, 30 minutes. It really depends on you and what you need. Either catching up on your understanding of atoms and elements, working on your understanding of the periodic table, or reaching out a little further by doing some quizzing. And I've got 2, the Chem for Kids quizzes and also PhET quizzes. And I know that some of you would like to work independently on these things. And some of you would like to stay here and you like to work with me. So if you're staying here, let me clear these, hold up. Don't answer, I'm going to erase them. All right, now you have to start over. So if you know where you want to go. Also, if you go to a breakout room and you can't move through the slides, please let me know, because that was the whole point. I was putting you in the breakout room as a starting spot, and then you can move through. There's 2 slides for each color. And so I'm going to start with turtles, going to red. And then if y'all need anything, you just come right on back in here with that little X. Okay, turtles are going to red. Loudspeakers going to yellow. I'm gonna just, loudspeakers are going to yellow. Good, lots of yellow. And then the OKs are going to green. Awesome. And then you guys are staying here, and I'm going to go through and kind of give you an overview of all of these. And when you find one that you want to work on, then you can work on them. All right, so our first thing, okay, yeah. Sorry, I'm looking for a website. I'm looking for my discovery education. So if you want to focus on building your own atoms, you want to log into discovery education with Google. And the best way to do that is to go to Clever. So I am going to go to Clever. And then I'm going to go down. I'm looking for Discovery Ed. Here, let me share with you. And this is Build Your Own Atom. Screen sharing. And I'm just waiting for the screen sharing. Okay. So I am logged into Clever, and then I'm going to go find Discovery Education, which is this blue D with the world on it. And I'm guessing that our Clevers don't quite look the same, but all right. And then you're going to search up here, build an atom. And here it's this one with the gray circle to build an atom. Okay, and then I'm gonna hunt down my chat box here, or my participant box. Okay, so you just scroll down a little bit, use the resource, and then so you can play around. You can put protons in the nucleus. You can put neutrons in the nucleus, and it will give you up here what's going on, what the charge is. I'm going to give it some electrons. I want to put these two in the first level and then go to the second level. So I know that I have 3 electrons and 2 protons. So what charge does that give me? 3 electrons, 2 protons. So that gives me a -1 charge. Right, to get your charge, you can take your protons minus your electrons, that would give us a -1. And you can see there's the charge, -1. We've got 2 protons and 2 neutrons, so how much mass do we have? Hey, Timothy. Yeah, we have a mass of 4. 2 plus 2 is 4. Atomic number is 2. So that's kind of the gist of this. I'll do one together. All right. I got tired of doing hydrogen. Done that a couple of times. All right, so let's build lithium. This 3 down here is the atomic number. So what do I need to add to get an atomic number of 3? Right, I need to have 3 protons, and I already have 2. So, okay, so there I've got 3. Now I need to have a mass number of 7. So how can I get a mass number of 7? 5 more neutrons. Two. Oh, I got a green check already. So we didn't have to add 5 of them. We just needed to add 2 of them to get our green check. And I like that it gives you a green check when you get this correct. So if you want to try this one out on your own, that would be in the red breakout room. So let's see, if you want to go try that one out, give me a red X just because it's red, and I'll put you in there with the directions. And if you want to see the next one, I will go back to my presentation. Also, oh, you forgot about the remaining neutrons. Yep. Hey, Akil. Hope you're having a good day. And I think I said, hey, Ian, good to see you. All right, so there's also a nice video on metalloids, but I'm not going to show you a video. So I'm going to move on. And I'm still at Discovery Education, but this time I'm going to go to Where Do I Belong? So this is periodic table stuff. Where do I belong? Where do I belong? Trying to remember. So, and I heard someone send me a private chat, but I haven't been able to get those today. So, but I'll check in a sec. Where do I belong? All right, and there it is. And again, I used Clever to log into Discovery Education to get to these simulations. Introduction. If you go and do this one, you can read the little introduction. Okay, so basically we're trying to figure out where do these go over in the periodic table. So for example, hydrogen is the lightest element in the universe. So where do you think I'll put that over on the periodic table? And hello, Anna. Hey, Dustin. I think I said hi to you already, but hello again. So where am I going to put hydrogen in the periodic table? It is number 1. Exactly. So drag it over there, drop it, and then it'll give me some information. It'll remind me that atomic number is protons. They call the atomic mass, they call it atomic weight. And so whenever you see weight, they're talking about atomic mass. And so chemists sometimes use those interchangeably, even though as a physicists, they are totally not the same thing, because mass is the amount of matter and weight is gravity pulling on the mass. But anyway, so you might see atomic mass labeled as atomic weight, but I don't like to use that term because it's really the mass. But anyway, that's perfectly acceptable. And so you get the idea on that one. All right. The next one was called, let's see, it's still in Discovery Education. Here's my search bar. It's called periodic table. I know. Oh, it's not giving me my choice. Hold on. There you go, interactives. This one, structure of the periodic table. So this one is structure of the periodic table. And there's some others in here too that are good. They're just more video related. And I know that you guys are watching videos for your lesson. Oh, what compound is made from titanium, molybdenum, thorium, and yttrium? Timothy, is this a joke that you're going to have the answer here? I don't know the answer. That was a good one. Okay, there's some information there, but I knew that was a joke coming. Okay, so here, you guys know which group this is. HENEARKRXE and RN. Where is this group going to go on the periodic table? We're basically going to fill it in. Maybe they're the alkali metals. I didn't even know I had the answer. Is that in the right spot? So helium, let's check. Oh no, that is not where helium and neon go. All right, so remove. Okay, go back. It's on the other end. Okay, so, oh, okay, so I put it over there. And then I can check. Good job. So I have put that one, and then it becomes color-coded with what's on the side. So, and you can fill them all in. And you can even show the atomic number if you want to help you put them in order. That's a nice little feature down there on the corner. Yeah, it's kind of like a puzzle. And you have to fit them all in. So if that is interesting to you, you can log into Clever and then go to Discovery Education and search for structure of the periodic table. And I'm going back to my presentation. So that was this one. It's in the yellow room. I mean, they're in all the rooms. And then for the green ones, we are going to, this is just a website, which I shall place in the chat just in case you want to quiz on your own here. So there are lots of different quizzes that you can take. These were the good ones that relate to what we've done thus far. So let's take one together. These are very basic quizzes. This is like the DOK 1 level information. This is Chem for Kids. But I think if, you know, this is a good place to start. You can build from this up to the DOK level 2 questions, but it's hard to do the level 2 and level 3 questions if you don't have the basics. So I think this is good. And they have lots of good stuff about all things chemistry. All right, so question number 1, how many known elements are in the periodic table? All right, so Maya's going with 100. All right, we're going with 100. There were actually closer to 100 elements when I was in school. Click over here. But now there are 118 elements, and they're actually working on 119 and 120. So I bet in the next year or so, we'll have 2 additional elements. All right, so how are elements in the periodic table arranged? Yeah, the people make the elements. They use like particle colliders, and they try to throw different nuclei together and make them stick. Yeah. And make a new element. Not quite like that, Kenny. Yeah. All right. So what organizational tool is used for the elements on the periodic table? I don't know if Hadron Collider is the largest one in the US or not, They do a lot of other things other than just making heavier elements. And I'd have to go and look it up to see if that's what they specifically do. And yeah, let's go with atomic number. Correct, that is the number of protons. But if you want to go look that up and bring the information back, I would be happy to hear about it. All right, which of these things is not listed on the periodic table? Ooh, Ian's going with orbital radius. And orbitals, remember, are just the electron levels. It's just a fancy word for the levels of electrons. And I'm clicking on the wrong screen again. That is correct. Which scientist came up with the correct concept of the periodic table? We're all typing and then not typing. Yeah, Dmitry Mendeleev. The rows are called periods, true or false? The rows, all the rows on the periodic table. The rows. Yes, that one is a true. And ooh, which of these is not a family of elements? Yeah, that's kind of a trick question there. The atomic number of an element tells you the number of blanks in a neutral atom. Okay, but protons, y'all, is not a choice. It says positrons. So make sure you're reading all the choices very carefully. The answer is also not none of the above. And remember it said this was in a neutral atom. And it's not the number of neutrons, because that could be more than the protons or equal to them. It's generally not less. Yeah, but remember, here's my, there they are, there they are. Oh, I lost my electron. All right, when you are neutral, you have equal numbers of protons and electrons. If you're positive, you lost electrons. If you're negative, you gain them. So they have equal numbers. So the answer there is electrons. No, you can't change protons. If you gain a proton, you become a different element. If you lose a proton, you become a different element. All right, the columns are called groups. True or false? Definitely true. And you'll find metals on the far right-hand side of the periodic table. That would be false, yes, because metals are over on the left over here. All metals, all nonmetals. Yep, nonmetals are over here. Metals are over here. Okay, next question, last question. Although the order of elements is based on atomic number, vertical families share similar chemical properties. True or false? Yeah, that's true. They're in the same family. So of course they have similar properties. Just like your family probably has similar characteristics. Well, Kenny, I'm glad you're still here. All right, so that is the end of that quiz. You could take several other quizzes there at that website. The last thing, oh, I better go get the link. Presentation. The last thing that I had on our list was to go to PhET to play the other games. Remember last time we played this game with the scales and the weight. And this time, though, we can play a different game. Okay. All right, so which game do you want to play? Do you want to play the periodic table, the element, or the question mark? Okay, we're going with question mark. So this is a mixture of everything. So notice the color here, that should help you out. This is the atomic number down here. So what should I put as my atomic number? All right, Maya's going with 1. Woo, so it's hydrogen. What about the mass? I don't think it goes up to 1 million. So the mass should be what, 32? Are you sure, Akil? I'm going back to 1. Because remember, mass are the number of particles that are in the nucleus, and there is only 1 there. And then what is the charge going to be? Oh, the atomic number, there's only 1 proton. So we're going to go, I don't want to click all the way up to 32. I'm going to check it. Yay, because our electron balanced out our proton, so we have no net charge. All right, so tell me, what should I put over here in my atom? A proton, okay. What else? A neutron, 2 electrons. All right, you ready to check? Oh no. All right, let's see if you can figure out the mistake. Oh, what if I take out the neutron? All right, because we need to have a mass of 1 and an atomic number of 1. And so that fixed it right up. I have a visitor. She's very fluffy. She's not a kitten though. She's a cat. All right, how about this one? What should I put down here? 17. How about at the top here? Is it 18 or 35? Remember, this is the mass. 35. It takes forever to click up to 35. Okay, and the charge? The charge of 17? Are you sure? Okay, remember, to get our charge, we take the number of protons and we subtract out the number of electrons. Protons minus electrons, and that'll give us our charge. I know she's clawing on my chair. Oh, I'm sorry, Ian. She must want something. I don't know. Want me to pet her? Okay, so let's check this one. And yay, we are awesome. She doesn't like hugs. She doesn't like me to pick her up. But she does like the attention. And she might be hungry. Who knows? All right, so how many protons does this chlorine atom have? 17. How many neutrons? Remember, this is the mass number up here. All right, we'll go with 20. And how many electrons? Oop, I saw someone wanted to put 21. No. All right, let's see if anyone else agrees with Anna or disagrees, or with Crimson about the 17 electrons. Yeah, I think that it was scrolling, and so I saw the 2 and then I saw the 1. All right, we'll go with 17. And check. Very nice, very nice. And one more challenge. So what should I put down here? Anyone want to agree? 21. All right, we'll go with 1. Oh, it's hydrogen. What about the mass up here? All right, so looks like we're going with 1. I'm only taking the answers that seem reasonable. And what about the charge? Thank you, Kenny. Timothy, I don't want to click up to 145 when I know there's only 4 particles here, so that's kind of out of the way. Remember, okay, to get charge, you take the protons minus your electrons. So how many protons do we have? And minus how many electrons we have. So we've got 1 proton, which is red, minus 2 electrons. You have an extra electron. We end up with minus 1. And so that may be odd to you because hydrogen does not ever form a minus 1 ion. Let's check though. Uh-oh, we messed something up. I'll tell you, the charge is correct. We did that right. So one of these other numbers is wrong. So the mass should be 2. Yeah, because look in the nucleus, there are 2 particles in the nucleus. Let's check it again. Whee! All right, 4 out of 5. So that is all of my simulations for today. Let's see, it is right at 2 o'clock. I want to bring everybody back real quick and just do a check-in on the equations or on the simulations. Hey guys, I brought everyone back from the green, red, yellow stop sign breakout rooms or stoplight breakout rooms. How did everything go? What simulations did you like the best? What did you get out of the simulations? And hey, Shanice. Oh, you're working on the lesson first? We were doing the simulations first and then go to the lesson. This website was the PhET one, and it's you can click right on the board there, phet.colorado.edu. They have wonderful simulations. Oh, good, Sanaya. I'm so glad that it helped. And if you ever need something to help you and you can't find it on your own, just send me an email or call me, and I'll be happy to get that to you. I'll put it in the chat. I think that when I'm using the magic wand pointer thing, that the links don't work as well. So can you click on it now on the board? The link should work better on the board now. Okay, so I wanted to go back. Any other comments about, yeah, it's weird. Any other comments about the simulations you worked with? Which ones were helpful? Oh, thank you, Anna, for putting that on the note board. Perfect use of the note board. Have you all used the Discovery Education yet this year, or was that a first-time thing? Excellent. I think that it houses mostly science classes. So unless you're in a second science class that actually has their curriculum there, maybe you haven't been there yet. So I'll continue to use those. I think they're good, good simulations, and they're just quick little practice simulations, so they don't take up too much time. All right, so I want to go back. I think it was slide 10. Yes, where we're working on today's lesson. So we still have some good time today for you guys to get through the metalloid lesson, get some help from me, work on your own. You know, this time is for you to kind of clear up what you need help with. So I am here to answer questions. And so if you want the quiet breakout room and you're good to work on your own, just give me that green check. And then we'll meet back here 10 minutes before the end of class to just check in and see how you're doing with metalloids. So a green check if you want the quiet breakout room. Give me any other emoji if you want to go back to the simulations. All the rooms, though, you should be able to page through the slides. Are you guys able to page through the slides in the breakout rooms? What about Mysterium? All right, I have brought you all back from the lessons. Oh, and Timothy's got steps here. Oh, so Timothy is working on tomorrow's assignment, which is the discussion. No, it doesn't include Mysterium, but you might be able to find another mysterious element there. Anyway, so tomorrow, that's a good point. Tomorrow we will be doing a discussion post. We'll be doing that completely during class, so no need to do that before you come in here. We'll work on that during class tomorrow. So any questions that came up about metalloids? Maybe, Timothy, you should start doing some research, and maybe you can discover a new particle and you could call it Mysterium. Or you can have it philosophically, yes. So no questions about metalloids? All right. I do have one practice question here. So which is not related to metalloids? Which is not related to metalloids? see. We'll see how obvious this is. I'll be quiet for a sec. All right, I'm waiting on a lot of answers here, but thank you, Alana, Maya, Sinai, Timothy, and Tristan for letting me know your answers there. Thank you, Solomon. Thomas, what do you think? Noah, Milana, Michelle, Ian, Dustin, Shanice, and Cheyenne, and Akil. Oh, good. I've got some more answers. Ooh, thank you, Solomon. Solomon's changing up his answer there. Okay, so let me just start here. And you guys can continue to answer or change your answers. I'm going to start here by thinking back to the beginning of class and that picture we had on the screen of the arsenic, which was metallic looking, it was solid, it was lustrous, it looked just like a metal. So turtle is not the answer because that is related to a metalloid. That's their metallic properties are solid and lustrous. And relating to its non-metallic properties, remember we talked about this at the beginning, and that if you were to smash that arsenic with a hammer, it would crack into a bunch of little pieces. And so it is brittle. So if you have unhappy face or turtle, you want to change your answers because those are both associated with the metalloids. I'm going to try this annotation because they were asking me if I could do it twice in one class period, and that is a no, it didn't work. Okay, moving on. Let's see what else people have picked. People have picked rabbit, and if you remember, one of the things we were going to look at today is to explain why metalloids are used as semiconductors. And so this cannot be the answer either because they do have their semiconducting ability. And it is easily manipulated by changing the metalloid that is mixed in with the silicon. So they take silicon as the base and then they add other little like germanium and other little elements in there to change the semiconducting properties. Yes, Timothy. All right, so it's not rabbit. And let's look at the OK. The OK, well, they are actually right here along the stair-stepper line. That is where they are. We've got boron, silicon, germanium, arsenic, tellurium, and acetane. So, okay, OK symbol is out. That is not the right answer either. And this one is also true with the thumbs up. As you add electron shells, which means you go down the different levels, they get heavier and more dense. And so then they become more like a metal because they're more solid. And the electrons are further out away from the nucleus, which makes them better conductors because those electrons can move around more easily. So the right answer was the loudspeaker, that they are gases at room temperature, which is wrong. Most metalloids are solid. I have no idea whose dog that is, but he's awfully cute, isn't he? I thought he was like looking right at all the different answers, so I thought he was a good one on there. All right, so questions about why this one's the right answer? Y'all have not changed your answers to loudspeaker. So once you understand why yours is wrong, you should try changing it to the right one. That lets me know that you are here working. It's the right answer because metalloids are actually solid at room temperature. All right, cool. All right, guys. Yep. Whatever I can do to help you all out, I'm happy to do that. But yes, you are special. You are why I'm here. I love teaching because of you guys. You guys are my students. And I enjoy it. I love coming to work because of you guys. So have a great afternoon. Thanks for coming in, and I will see you all tomorrow. Bye.